Thank you very much. It's my pleasure to now invite Dirk Schmeller from the Institut National Polytechnique in Toulouse to talk to us about biodiversity loss, emerging pathogens, and human health risks.
Yeah, good day, good morning. No, good day. It's good day, everyone. Thank you also for being here. It's an honor for me to give this presentation. Especially, I'm a very good tick and mosquito attractant. Whenever there's one somewhere, it's on me. So it's quite interesting to see. But with my talk, we will move a little bit away from humans and go more into environmental and ecological questions around the topic. So my talk is about the loss of biodiversity, emergence of pathogens and risks to human health, which is also the part of the research I'm doing for my AXA chair on functional mountain ecology, and might become a little bit clearer what it is about. I don't go into much detail. I just wanted to give you an idea what biodiversity means, because maybe not everyone knows. It's all the variety of life forms on Earth, and it's actually considering the diversity of ecosystems, species, and genes over space and time, but also all the interactions between different species, between different genes, between the environment, and so on. All of this is actually part of biodiversity. When people talk about biodiversity, they usually mean species numbers, species richness. It's a little bit more than that, but what's interesting to know is we have 1.7 million species which are described. That's about what science knows. There are 7.3 million species estimated. However, this estimation does not include bacteria, fungi, and protists. Of those species groups, we hardly know anything. Most of them are unknown. So if we take that in consideration, we are not talking about a million species, but about billions of species. So it's just, you need to keep that in mind, because this massively increases the possibility of interactions between different species. So this is massively simplified. It's a network. If you imagine each of these dots would be one species, there is quite a lot of possibility of interactions between species, between different genes within the species, between the species and the environment, and then also between the genes and other molecules like hormones and others. So this is, of course, hugely impressive, but we also have the climate on top of this. So we have an unimaginable number of potential interactions. It's mind-boggling, and that's why also modelers are not getting there in modeling really the environment. Sorry to say, but it's like this. But there is a huge amount of possibilities. But what we are doing at the moment is driving an important biodiversity loss. Secret, since I'm born, 1970, there is a decline of 60% of biodiversity. And this is most likely an underestimation, because we have very little idea what biodiversity was before 1970. There are a few species groups which go back a little bit further, but most of the information we have is, more or less rudimentary. And what few people actually do know is that we are living in a period where biodiversity is particularly important. If we go back in time, in millions of years, when there were the trilobites, these are the number of families there were not so many different families. There was a certain drop in time, so these are the different mass extinctions we are seeing. But since about 200 million years ago, we see an increase of biodiversity over time. And we are not knowing at the moment where we are going with what we are doing to the planet. I guess it's not the right direction, but this is what the current status about biodiversity is. And this is about an idea, it dates a little bit back from 2014, but this is the increase of infectious disease outbreaks globally. So you see, it's quite a massive increase over time, and these outbreaks are driven by quite a range of different pathogens. Pathogens per se are nothing dangerous and nothing unnatural, mean or anything. They are there. They have a role to play in ecosystems because they challenge other organisms and then they eliminate sick and weak individuals. That's their job. That's what they do. Yeah, and if that's a bacterium, protozoans, fungi, viruses, or worms, that's the job they do. But what we see and what we have seen over the last 2 years is that there are possibilities of spillovers. Naturally, these spillovers are very difficult. They are very improbable because there are many different layers which need to line up that kind of their pathogen falls through the holes and getting to humans. One of their first pathogens which changed in primates is the simian immunodeficiency viruses, which became human immunodeficiency virus after having been switched between the two hosts for quite a while, and only when it got adapted to the human host, the spread between humans was becoming possible. So there are a huge amount of different factors I don't have time to go into, but which need to be met so that we are really seeing such a spillover. And this spillover is very complex and multifactorial. Natalie just has spoken a little bit about this for the tiques, but for any kind of pathogens, this is what it is. It's very difficult, and it's resulting essentially from the interaction between microorganisms itself and also the human activities. And we need to have the microbial adaptations, we have to have the ecological changes. It's linked to human demography and behavior, to poverty, social inequality and lack of political will. This goes back to the syndemic term. We have also differences in technology, industry, and healthcare, transferring organs and so on. Well, this comes also with risks to transfer pathogens. We are traveling much more and further, so we are moving around a lot of different microorganisms and parasites due to this. There is also a change in susceptibility to the different infections. So this is just more or less a brief overview of what there is. And my own work has pretty clearly shown that in mountain lakes, in which I am working primarily, zooplankton is actually a biological barrier against pathogens. It's consuming the infective stages of fungi. In this study, it was Batrachiochytrium dentopatidis, which is an amphibian fungus. And it's just feeding on the zoospores. And by feeding on those zoospores, it's protecting the host. If we don't have the zooplankton, and here you can see some very bizarre and fantastic forms, well, then more zoospores become available and the pressure of infection becomes more important. So if you look further into this, we need to go a little bit smaller and have a look, okay, so what about all of those microorganisms which form the microbiome? They have a huge amount of different functions in the host in the first place. They can help to increase temperature tolerance, which is, of course, something good in climate change. They might shorten the time of adaptation to environmental change, which in the presence of humans is also a good thing. They are forming biological barriers on the skin or inside our intestines and so on. So this is also very important, and it's an important part of the immune system, to be honest. So it competes with pathogens and can help to mitigate diseases. Well, and the major gift all of your mothers have given you when you gave birth is they transferred their microbiome to you. And this helped you also to be more easily able to synthesize vital nutrients, to take up the energy and to grow, to become the adult you are now. But of course, this also all influences the host behavior and reproduction. But you can actually transfer all of this away from a host to an environment. Microorganisms, microbiomes in the environment have very similar functions. They are there to help buffer against change. They maintain biodiversity. They maintain ecosystem processes. They are, as shown with my zooplankton, also an environmental barrier against the introduction or the invasion of alien species, and therefore they contribute to the resilience, and the tolerance of ecosystems, and therefore constitute the basis of ecosystem health. What many people working on, also in my research unit, is the ecological functions like nutrient cycling, energy flux, CO2 sequestration, which is very much what it does also in our intestines. So there are a lot of similarities, and this brought us to propose a new concept or an evolution of the disease triangle, which many of you might know, and include the host microbiome as a fourth axis. So the disease, which is here in the middle, either no disease expression or weak disease expression until death here in the center, is then the result of the interaction between the host microbiome, the pathogen, and the environment. Only when you take all of this in consideration, you will really have an idea what we need to expect. And we are currently working on biofilms in aquatic environments, but in many cases also our gut microbiome is actually organized in a sort of a biofilm. And the particularity is that it's a community of different microorganisms which are living in a matrix of polysaccharides or other proteins, which are then kind of building villages of different microorganisms. And we have no good idea at the moment how we can influence pathogenic biofilms. Well, we can eradicate them and kill them, but that's maybe not a good thing. We have the beneficial biofilms, which we are treating badly by having some burgers, a lot of sugar, or whatsoever bad habits we have for food. But we also have no idea how all of this is linked to the environment in which we are in. I mean, some of us, and I'm one of those, when I was a kid, I loved to play in the mud. That's something very important to do. Because you are then putting a lot of different microorganisms in your mouth, and your body is challenged. But in a general term, we don't know what really happens. We don't know what happens with the urbanization we are seeing all around. But we know that those biofilms are very essential for ecosystem functioning, for the stability of ecosystems, and therefore also for ecosystem health, with repercussions for human health. But what we see in mountains, and mountains are particularly strongly hit by climate change. In the Pyrenees, we are already at an increase of 2 degrees, roughly, where we are but at about 0.8, maybe 1 degree in lowlands. The impacts of climate change are therefore very drastic. And what we saw over a rather short period of time of 5 years is actually we see a significant loss of biodiversity in prokaryotes over time. And this is also, there's a certain equilibrium there. So not one super dominant species necessarily, but this has changed. It becomes more and more uneven. And this is a biodiversity loss which goes unperceived by many because it's so difficult to see and so difficult to observe. Because you cannot only go out there and have a look and say, well, we have less species there. No, you need to sample, you have to have the dry ice with you, you need to go down to the lab and have a long period of lab work behind, so this is nothing which goes easy. But this is an important part, because if we lose this microbiome, there will be important repercussions. And what we see, and sorry, it's a lot of different graphs, but the redder it is, the more dangerous it is, means that here we are looking at cyanobacteria. And the red ones are for sure toxic, and the orange ones we are not yet sure, or there are different lineages. Some of them can be toxic and others are not. And what we can see is actually that the relative abundance and the richness of those cyanobacteria is increasing to the detriment of other microorganisms, and many of those are toxic. So this IS is a very good example, because it's very easy to see the increase of the red and the orange part over time. Yeah, so this means all the influences we see from climate change and also pollution, I'll come to that in a sec, are changing these communities, and therefore also the ecosystem health and the stability. The proliferation of those often toxic cyanobacteria will have an important impact, which then can also impact on us when we drink the water from those lakes. So what we are actually doing at the moment is we think we can build this, but what we actually can build is that. Yeah? So we are hugely overestimating our abilities to what we are able to do. And if you have a look at this biodiversity, we are nothing else than kids playing with something they don't really know. And destructing it is quite easy, but rebuilding it is a very difficult task. So by not taking care of our ecosystems, of our global life support system, what we do is we are destructing these biological barriers. What happens then is there are different pathogens can enter in that ecosystem. If that ecosystem has the right conditions, and we are presenting them more and more often, that case, well, they then also proliferate. And with the proliferation of these microorganisms, we are increasing the probability of infection. If you had 1 in a million liters of water, well, that you catch it is quite improbable. But if you have 1 million in a million liters of water, it's quite a bit more. Yeah, and this is something which is really important to keep in mind. And especially, we do not have a linear loss of biodiversity. What we are expecting is jumps, because there is a certain ability of biodiversity to buffer against temperature increase. But once it's too much, biodiversity will not be able to do that. And then we will see a massive loss of species in a very short period of time. So we are getting to those projected limits of buffer capacity of biodiversity. And this is something which we need to consider when we are talking about biodiversity in general terms. We have done an analysis which made a little bit of a buzz. There were articles also in Le Monde where we had a look on the pollution, chemical pollution of organic pollutants in mountain lakes. And we looked for all possible molecules which we are able to detect. Is 479. We found 151. And we see a lot different ones. We have still sometimes DDT, but sometimes also products of DDT. We have insecticides, we have fungicides, we have herbicides, and many other compounds. And if we look into the toxicity, for example, crustaceans, in all of our lakes, we had at least a chronic toxicity. So this chronic means it has an impact on biodiversity. It's maybe not a very strong impact, but it has an impact. But what you can see here, we also have quite a few which have acute toxic risks. So it's killing crustaceans. Yeah? And if we have a look on this, our numbers on crustaceans is pretty clearly showing that where we have acute toxicity, there are very few or no crustaceans left. And crustaceans, what do? They clean the water. When you go to the mountains, you expect clean, transparent water, no troubled waters. Well, if the crustaceans are gone, this will change. And with that, we will have a proliferation of toxins from cyanobacteria and maybe a proliferation of pathogens. And that's a huge problem for biodiversity. But this toxins we have seen, there are also quite many endocrine disruptors in it. Yeah, so we know that endocrine disruptors don't need to have a huge concentration to be effective. So it could be that when you go to the mountains and you let your kid drink from the mountain water, it might develop some deficiencies in its development. So this is really something which is important to keep in mind. I see that my time's getting a little bit closer. I'm not going into details here, but this is something we heard before. There are new vectors. Water quality is a problem with cholera, Campylobacter, and so on. We have impacts on water and food supply, and we are not safe here in Europe neither about this. The mountains at some point will have difficulties to provide what they have. And what we need to understand that our health is very closely linked to environmental and ecosystem health. If we want to continue what we do right now, population growth of human population will end very quickly and not very nicely. So this is something which we need to keep in mind. And those who are most unfavorized in our societies are the ones who will be the first paying the price. It goes back to the term of syndemics, where people who are badly nutritioned, who are maybe abusing drugs, and drugs that can also be smoking and drinking alcohol excessively, unhealthy food and so on, they are more susceptible to pathogens, to infections. Yeah, and this is something which is really important to keep in mind, because we are all living in a card house. If we're taking out too many of those cards, we will just fall on our noses. And this is something which is kind of the message I would like for you to keep in mind. You can find some videos of mine on a YouTube channel, which might also be interesting for some teaching. I also, if you are interested to learn a little bit more, it's more for the French speakers here, about the research we have been doing in the French Pyrenees since 2009. There's actually a book out for the general public, which gives you a little bit of an idea what we do, and gives you the backside of science. So it's not only that we go there, we find what we look for, and we go back. It's a little bit more difficult than that, and maybe it's interesting for some of you. Thank you.